Today we're going to start mixing all the different types of factoring together, and our job, our trick, is going to be trying to figure out which one to do it, how to do it, and when to do it. Okay, so starting at the top of our flowchart, and I hope you printed off the flowchart. This is sort of something you can use over and over again as you're working your way through factoring. If you want to, you could add to your learning goal sheet, I suppose, even. But really, the flowchart tells you which thing to do and what order to do them in. Hey, when we work on a flowchart, we always start at the top. So our first objective on a flowchart, common factor. If you can common factor it, you want to do that. It will simplify your polynomial, make it easier before you ever start looking for the other types. So we look at the first one here, the 8m cubed one. Okay, what's my common factor? Well, the biggest thing I can take out of both of those would be 4m squared. And if I do that, I'm left with 2m minus 1. Okay. Common factor first. A letter, a number, an exponent, the biggest thing you can take out of everything. You always want to do that first. Okay. And then you want to start checking your brackets. Can I go further? Okay. Now the question you have to ask when you always factor is, can I go further? So maybe put in the star up at the top of your flowchart here. To factor beyond common factoring, okay, you must have an even, that's the key there, even exponent as the largest exponent. Okay, so if I look at this common factoring that I just did, and I check out my bracket, that's the brackets I want to talk about. The largest exponent I see in there is a 1. Well, that's not an even exponent, and because it's not even, I cannot go any further. I cannot factor. That's it. That's all. I'm done. That's sort of the way of checking it. Okay, so we've common factored. The next thing we want to do is we want to start counting the number of terms. So on your flowchart, you have 3 choices. The 3 choices are 2 terms, 3 terms, or 4 terms. How do I know which one's which? Well, if it's a 2-term expression, okay, I have to ask myself 2 questions. First question, is there a minus sign between them? If your answer is yes, next thing you want to check is, can you square root both terms? If the answer to that is yes, well then you absolutely positively know it's a difference of squares. Okay? 2 terms, a minus sign between them, and you can square root both. How do we do difference of squares again? Well, okay, we're going to square root both terms and put opposite signs, so one positive, one negative, in each bracket. And by each bracket, I'm saying there's 2 brackets, right? So let's take a look at this one. There's 2 terms. There's a minus sign in the middle. I can square root them. So let's do that. The square root of 81k4, 9k squared. Square root of 1 is 1. And with the exact same things out in the other bracket, 1 plus, 1 minus. And then I check my brackets. Can I go further? Okay. I got an even exponent. That means I can maybe go further. I check out my first bracket. 2 terms. Sounds like a difference of squares. But there's a plus sign. Rule number 1 said must be a minus sign between them. So I can't go any further with this bracket. This bracket right here is done. The second one, 2 terms. Minus sign between them. I can square root both things. This bracket can go further. What this can look like is a second difference of squares. Now, a second ago I said you can't go any further, but we still have to write it down, okay? That's our first factor. The second one, square root of 9k squared is 3k and 1. 3k and 1, put different signs between them. Check if you can go further. The first bracket we already said you couldn't. The second bracket, I don't see any even exponents. Can't be factored. Third bracket, I don't see any even exponents. It can't be factored. That's it. That's all. I'm done. And that's how we do difference of squares. Okay, back to our chart. And that was 2 terms. What happens if there's 3 terms? If there's 3 terms, I have choices. Is the value in front of the squared term 1? Is it just x squared? Well, if it is, that tells me it's a simple trinomial. Yeah, simple trinomial, 3 terms, Nothing in front of the square term, it's just a c squared. Okay. How do I do these ones? I find two numbers that add to the middle and multiply to the third term, or the last term. So I need to think of things that add to 21 and multiply to make 100. Okay, what would work? C and C make C squared. Things that multiply to 100. So I got choices. I got 1 and 100. I got 2 and 50. I got 4 and 25. I got 5 and 20. 6, 7, 8, 9, 10 and 10. Okay, I need something to add to 21. Well, 1 and 100 definitely don't. 2 and 50, no. 4 and 25, that'll work. C plus 25 and C minus 4. The order's not important, but those signs definitely are. Check your brackets. Can you go further? I don't see any even exponents. Can't go any further. We're done. That's it. That's all. Now that's what happens if we had a simple trinomial, because our question was, is the a value 1, this number in front of the square term? If it wasn't, well then I'd have a complex trinomial. And these are the ones we did yesterday. These are the ones with the process. And we'll write the process, just to remind ourselves again. Step 1, multiply first and last. So in this case, it's going to be 4 times 3 is 12. Terms that add to the middle and multiply to the new term. So we need to think of things that add to -7 and multiply to 12. And if I'm thinking about that, I think the numbers 4 and 3 would multiply to 12 and add to 7. But if I change those to -4 and -3, they'll make -7. Okay, step 3, replace middle term. Okay, so we just said a second ago, the numbers would be -4 and -3. Okay, so replace the middle term with those things. Step 4, split in half and common factor. Okay, so I go down the middle. I take a 4x out of the first thing. Carry down my sign. We always said that sign goes down here. They'll both have a 3 in them. And if I do that, 3 divided by 3 is just x. Positive divided by negative is a negative. Hey, looks good. My brackets are the same. So the last step is common factor again. I take that common bracket out, the common expression. And there's our complex trinomial. I knew it was complex because my number at the front was a 4, and I can't common factor out that 4, right? They're not divisible by 4. Okay, so there's the 3-term expression. The only thing we got left is a 4 plus term expression. When I say 4 plus, we're only ever going to deal with 4 in this course, but it could be 6 terms or 8 terms or 10 terms or any even number of terms. In that case, we call this something we call grouping. Okay? Can we group the items to create a common factor? So the answer is yes to that question. Okay? Can I split this in half? Okay, split in half and common factor. If that's possible, then we've called this factoring by grouping. So if I look at this one here, cut it in half, I can take an x out of both of those things. 2a minus 3b. The second one, my sign comes down, I can take a y out of both of those, and I get 2a minus 3b. Hey, look! I end up with a common factor. So what do I do? Split in half common factor? Common factor again, right? Sort of like we're doing a complex trinomial. Okay, take out the expression that's the same. So they both have a 2a minus 3b in them, and with x minus y. Okay. If it's not possible to common factor this thing, it had nothing in common, well then we'd stop. At this point, that's all we know. Okay? There's no other types of factoring that we're aware of. You're done. You know, I'm going to tell you right now, we're always going to have things we can factor. It'll be the rare case where we don't. But let's practice them, okay? Well, my suggestion here, I'm going to go through all of them, but you take a second, try them yourself so you can figure out which one it is and how to do it. There's, what, 8 of them or so? Okay. If not sure, come back, check in with me, see if you got the right answer, if you thought of the right idea, and then move on to some factoring. All right, first one. There's no common factors. There's 3 terms. The thing in front, just an old x squared. This is a simple trinomial. I'm looking for numbers that add to 11 and multiply to 24. Numbers that do that, x plus 3, x plus 8. Second one, no common factors. Oh, but there's 2 terms, a minus sign in the middle, and I can square root it. That means it's the difference of squares. I square root the first thing, square root the last thing. 2 brackets, 1 plus, 1 minus. Check if I can go further. No even exponents. Done. Okay, third one. Start at the top. Common factor. Hey, these both have a's in them. And in fact, they both have 3 a's that can be divided by. If I do that, I get 2a minus 3b. Hey, check my brackets. Can I go further? Nope, no even exponents. Must be done. Yes, that one literally was only a common factor, right? The starting point. All right, D. Look at these 3 things. No common factors. Can't divide them by something. Count my terms. There's 3 of them. The number at the front has a number in front of it. That tells me this is a complex. This is a long one. 6 times negative 10, negative 60. What adds and multiplies? Numbers that work. Negative 15 and positive 4. So I'm going to replace negative 15 and positive 4. Okay, split it in half. Common factor the first half. I can take a 3x out, 2x minus 5. Carry down my sign. I can take a 2 out, 2x minus 5. Hey, I'm on the right track. My brackets match. The common bracket comes out, and all the leftover stuff goes in the other bracket. And there's the first 4. See how you're doing. The next 4. Okay. No common factors. Number up front. It's a complex again. We got 2 of these in a row. Okay, let's try this one. Okay, complex. What adds to 20 and multiplies to 100? Oh, 10 and 10 will do that. So let's replace. 10a, 10a, 25. Common factor. They both have a 2a out. 2a plus 5. These are both divided by 5. 2a plus 5. I'm on the right track. Look, my brackets match. I know I'm doing this right. 2a plus 5 and 2a. Hey, it's the same bracket twice. So we know we could also write this as 2a plus 5 squared. Okay. Let's look at F. Common factor. Hey, 3, 3. Let's see if they're divisible by 3. 216 divided by 3 makes 72. Yeah, they are divisible by 3. That's common factor. Okay, what am I left with? I got something inside. It's got an even exponent. I may be able to factor this one. Let's try it. I got 3 terms. Looks like a simple trinomial. But adds to negative 1 and multiplies to 72. Things that multiply to 72. 8 and 9. 8 and 9 will work. Minus 9 and plus 8. Okay, so that was a common plus a simple trinomial. Let's look at G. Oh, now here's a trick one. G is on the right order. We always want our squared term first, followed by the letter term, followed by the number term. If it's not in the right order, you make sure it's in the right order first. Now this looks like a simple one. What adds to 11 multiplies to 18? Numbers that do that are minus 9 and minus 2. I can't go further because I have no exponents. Let's try H here. 5 and 20 are both divisible by 5. Let's take that out. All right, check my brackets. I see an even exponent. Maybe I'll go further. I got 2 terms, a minus sign between them that looks kind of like a difference of squares. And if I do that, I end up with that expression. I got one more stuck over here. It looks like letter I. Okay, letter I. Oh, well, it's one that messes everybody up all the time. Okay, I is simply a simple trinomial. Okay, there's 3 terms. The part that messed me up was the letters. To get x squared at the front, you need 2 x's. y squared at the end, you two y's. What adds to 4 and multiplies to 12? Minus 6 and plus 2.